So we're going to be looking at problems from chapter 4. So let's look at the first problem. Now we are looking at time value money problems that have different cash flows in different years. So one of the ways to solve a problem like this, again, we start by putting it into a timeline. So that's 4 years, 1, 2, 3, 4. Cash flow is 100, negative 100, 200, negative 200. So one of the ways in which I can calculate the present value is to take each cash flow and convert them into their present values. And then I will add them up. So the present value of cash flow 1 is 100, which is the future value, divided by 1 plus R. R is 15%, so that's 1.15 raised to the power 1. So essentially, this formula over here that I'm using is present value equals future value at a future time period n divided by 1 plus the interest rate raised to the power n. So in this case, n is 1. In the next case, it will be negative 100 divided by 1.15 raised to the power 2. The next one would be 200 divided by 1.15 raised to the power 3. And the last one would be negative 200 divided by 1.15 raised to the power 4. So I can take each one of them and then I will add them up. That's certainly one way of doing it. The other way of doing it, of course, would be to use our financial calculator. Let's see. My financial calculator is here. Let me open this up. So I'm going to clear everything. Second, clear TVM. Now for this type of a problem, as you can see, I have multiple cash flows. So there are two ways again I could do it. I could take each cash flow, like this cash flow, calculate the present value, second cash flow, calculate the present value in the financial calculator using the method that we learned in chapter 3, and then add all of those cash flows up. Add all of those present values up. Certainly that's one way to do it. The other is to use the shortcuts that the financial calculator affords us, but this time the sequence is slightly different. I have to go into this cash flow register, CF. It brings up this screen. I have to do a second clear work, second and CE, that clears again any previously stored values. Now I'm ready to enter my cash flows. So my cash flows are C1, C2, C3, and C4. 4 different cash flows. Although these two numbers are the same, but they're not the same cash flow because they're negative. So CF0, I have no cash flow in year 0. Year 0, there is no cash flow. So that remains as 0. Then I do a down arrow, which is at the very top over here. That brings me to C01. C01 is 100. Enter. F01 is 1. For the moment, just keep it as 1. Later on, I will show you how to change it for different types of problem, but for now, just keep it as 1. Then I go to C02, which is 100, but negative sign. So I put a negative sign, and I go down arrow. C01 is 100, C02 is 100, negative, enter. I have to click the enter key that accepts a value. Then I go to C03, which is 200, enter, down arrow. F03 remains as 1. C04 is 200, negative, enter. So now I've entered my cash flows. I can scroll back and see C03, F0s, all the F's remain as 1. C03 is 200, C02 is 100, negative 100, and C01 is 100. So I've entered all of those cash flows. You can scroll up and down to make sure that the numbers that you entered are all correct. Then I will click the NPV key. When I click the NPV key, the display says I equals. So the calculator is asking me to input the discount rate. The discount rate is 15%, so I have to input that. So I put 15, enter. And then I go down arrow. Now the calculator screen says NPV. So what I am calculating as present value, in the calculator it is being, the calculator is using the word NPV, which we will see later what it exactly means, but for most purposes it means the same thing, present value NPV. For the most circumstances it will be the same thing, but at least in the context of chapter 4 problems, later on we'll see how it may be changed, amended, depending upon a different context. So to calculate net present value, all I have to do is click the compute key, and that gives me 49.83 as the present value of those cash flows. I want to check my numbers again. So CF0, C01 is 1, C02 is negative, C03 and C04 is negative. Okay, so that gives me net present value of 20. So its net present value is 28.49, not 49. It's 28.49. So present value is 28.49. Okay. Now we go to another type of problem. Over here, again, we have you have $5,000 balance on your credit card with interest rate charges of 1.5% per month. Looking at your budget, you figure you can make the following payments. Will they be enough to pay off your credit card? So again, these are payments in the future. Year 1 payment, year 2 payments, year 3 payments. So either you can pay off all 5,000 today, or you can use the following payment structure to pay them off. The following payment structure to pay them off. So how would you, which one would be, one way to look at it, should I pay them off pay off the entire balance today? Or should I lay it out in this cash flow format and will it be enough to pay off my balance? So one way to compare this is to take the present value of each of these future cash flows. Again, similar to the problem that we did earlier. So you will take present value, again present value is future value in period n divided by 1 plus r to the power n, and you will apply this formula to each of these cash flows. They're all different. And then you will add them up and you will see what the number tells you. Alternatively, I could use the financial calculator. I go back to my CF key and I do a second clear work. Once I do it, you can see everything is cleared out. And I will re-enter my numbers. There's no CF0. My first cash flow is year 1 cash flow. So that's C01, that's 500. Enter. C02, 550. Enter. C03, 600. Enter. C04, 650. Enter. C05, 700. Enter. C06, 750, enter. C07, 800, enter. And C08, 850, enter. So I've entered all of the cash flows. You can go back up and scroll through and make sure they've been entered correctly. Notice I have not changed any of the F's. All of the F's remain 1. That's the default number. Having entered everything, now your monthly interest payment is 1.5%. So I go back to NPV. I enter that as my interest payment, 1.5 per period. There are 8 periods, 8 months. This time, for this particular problem, each period happens to be a month. Sometimes it could be a year, sometimes it could be a month, sometimes it could be days. In this case, it's month. And then I scroll down to NPV and I compute. So all of that adds up to a present value of 5,023, which means these cash flow payments are sufficient to pay off my loan of $5,000. Okay. That's problem number 4. Let's take a look at problem number 10. You have a loan outstanding. It requires you to make 3 annual payments of $1,000 each at the end of the next 3 years. Now the problems are getting a little bit more wordy, so you need to be very careful in reading the problem and immediately start transcribing the information into relevant variables and underlining them. 3 annual payments, $1,000 each. Those payments occurring at the end of each year. Your bank has offered to allow you to skip making the next 2 payments in lieu of making 1 large payment at the end of the loan's term in 3 years. If your interest on the loan is 5%, what final payment will the bank require you so that it is indifferent to the 2 forms of payment? Okay. So here we have first of all, what you need to do is evaluate the first alternative. The first alternative is, we can put this into a timeline. One, 2, 3. Each has a payment of 1,000. So if I were to pay this as a regular payment of $1,000 each of the next 3 years, I can ask the question, what will be my present value of this payment? So take the present value of each of the 3 cash flows, add them up, and find out what the present value is. Kind of like what we did in the previous 2 problems. With one small but interesting change over here. The small interesting change is that all these cash flows are of the same amount. So by definition, this is an annuity. And I'm going to use a different technique to solve for the annuity. I could use the formula, but as we have learned in class, we will rely on the calculator method. Since this is an annuity, let me bring up the calculator. I clear everything, do a second clear TVM. Since this is an annuity, my payment is 1,000. I have 3 years for my annuity, and my interest per year is 5%. 5% loan, so it's a 5% interest. So I'm going to enter 1,000 as my payment this time, not future value. Since it's an annuity, same amount in each of the next 3 years. That makes it an annuity, so I enter that as a payment. N is 3, IY is 5. I'm going to compute present value. So the present value of these three cash flows is 2723. Present value is 2723. This is what I computed. I computed this present value. So that's one choice I have. The problem also says that if the bank allows you to skip if the bank allows you to skip the next two payments, what is the final payment that the bank will require? So now the bank is telling you, don't need to pay this, you don't need to pay this. What will be the final payment that you will have to make so that you're indifferent? The key thing is you're indifferent. So now in terms of the timeline, notice what's happening. I have to calculate my payment in year 3. What's going to be my cash flow in year 3? Or my future value in year 3? What's the invariant over here? What's the indifference? The indifference is this number. That final payment, its present value has to be 2723. So essentially the problem then is, I have a future value in year 3 that I do not know. I have to compute. The present value I know is 2723. IY is 5% and N is 3. So I have to compute future value. I have to compute this. So I go back to my financial calculator, clear everything, do a second clear TVM. Present value is 2723 negative. Present value. IY is 5%. N is 3. And I'm going to compute my future value. So that will be 3152. So it will be 3152. So either I make a lump sum payment of 3152 in year 3, or I make 3 payments of $3,000 in each of the next 3 years. Problem number 12, you want to endow a scholarship that will pay $10,000 per year forever, starting 1 year from now. If the school's endowment discount rate is 7%, how much must you donate now? This is a typical problem that foundations run into. You want to create an endowment that pays $10,000 each year. $10,000 each year, and there is no endpoint to it till infinity. Now notice what this cash flow represents. It's the same amount each year, year 1, 2, 3, 4, all the way to infinity, and it does not end, ... So this type of cash flow we call a perpetuity. So to get that stream of cash flow at a discount rate of 7% or R of 7%, how much money should I deposit in the bank today? So my unknown is present value. And the present value of a perpetuity is cash flow divided by the discount rate. So cash flow is 10,000 divided by a discount rate of 0.07. So I go to my calculator. I don't need to use financial calculator keys over here, but it's 10,000 divided by 0.07, which is 142,857. 142,857. So with this donation now, you can ensure $10,000 recurring payment forever. And we solve this question as a problem for perpetuity, and that's the present value of a perpetuity. Question number 17, assume that your parents wanted to have 160,000 saved for your college by your 18th birthday, and they started saving today. They saved the same amount of money for each of your birthday that earned 8%. How much would they have to save each year? So now, for your 18th birthday, in year 18, your parents need 160,000 to send you to college. How much would they save in each of these years? 1, 2, 3, 4, all the way till 18. So, the unknown that we have are these cash flows. But we know they have to be saving, the problem said they're saving the same amount. And their savings will end at a certain period of time. So those two give me a clue that this is an annuity. So same cash flow each year. So now in terms of a time value money problem, this 160,000 represents the future value. These stream of cash flows will represent my payment. So payment is my unknown. Future value is 160,000. N is 18, and it is going to be saved at 8% per year. So interest per year is 8%. So I'm going to be computing I'm going to be computing payment. So clear everything. Clear. Second, clear TVM. 160,000 represents my future value. 18 is my N. IY is 8%. I'm going to be computing payment. So they have to put away $4,272 each year. $4,272. 4,272 is the payment. 4,272 each year for the next 18 years, so that will accumulate to a saving of 160,000. The last problem we look at is a growing perpetuity. The first payment, and the problem tells you it's a growing perpetuity. And we know that the present value of a growing perpetuity is C1 divided by R minus G. So our task is to identify what is C1, what is R, and what is G. The first payment will occur a year from now, which is 1,000. That means C1 is identified as 1,000, a year from now. A year from now, that's the key. Each year after that, you will receive a payment that is 8% larger than the last payment. So what does that information tell us? That's our rate of growth, G. G is 0.08, and this pattern will continue forever. So that makes it a perpetuity. Assume that the interest rate is 12%. Okay, what is the value of this bequest today? So that we are asking for present value. So it will be 1,000 divided by 0.12 minus 0.08. 1000 divided by 0.04 is 25,000. That's the value of the bequest today. What is the value of the bequest immediately after the first payment is made? So what will be the value a year from now? Well, since it's a perpetuity, its value still remains as, so present value in year two, a year from now, so this is year one. So present value in year one will be cash flow in year two divided by R minus G. So cash flow in year two will remain 1000, will not be 1000 now. Cash flow in year two would be 1000 times 1.08. Cash flow in year one was 1000. Cash flow in year two will grow at 8% of that. So it's 1000 times 1.08, and then I will divide that by 0.12 minus 0.08. So it will be different than what the present value is right now. So our numbers would be, we will divide 1000 times 1.08 divided by 0.04 divided by, clear this, clear everything, 1000 multiplied by 1.08 divided by 0.04. That will be 27,000. So the present value, the bequest, the value of the bequest, if I delay starting this a year from now, that will become 27,000. So that completes some of the problem sets for chapter 4.